All right, moving on to product design. Things like engine control modules, electronics, looking at defroster patterns. We used to use thin wax on our windows, our windshields, and watch those defrosters melt the wax. Kind of an archaic technique. Once we have infrared, the glass is a pretty good emitter, and we can see defroster patterns right away. Exhaust systems, where's the heat going? Hopefully out the back. Is it melting ice cream in our trunks? Hopefully not. It's the heat we want out the back. So looking at floor pans and where the heat is going in the exhaust system is very, very important for customer satisfaction. Radiator efficiency, lamp designs. Every time we go to a new material, we have to worry about what temperatures are being reached. So we'll put it in, reach steady state, and analyze that image. Power distribution panels, watching if they can handle the power, the amperage is very critical. Especially when our suppliers might ship us some defective or maybe parts that don't meet spec. Then what do? We have to quickly analyze. A supplier is not going to come to you and say, we oopsed. It's going to be up to you folks to find those problems, explain to that supplier what he's doing wrong, and hopefully get him to correct his ways. There's been hundreds of times where we know something's wrong, we've got scrap parts, and the supplier swears they haven't changed the process. Then when we rub their nose in it, they go, oh, we forgot to tell you we did tweak this to get production up, but we're making scrap, okay? We didn't know how to tell you that. Also in tire testing, another great application. Tires are very good emitters of infrared and can be good targets for thermal studies. In the area of electronics, each one of those has a signature that's important. We try to exercise those to get full power into that board before we do a buy-off. We look at the designs of those boards. I've been at Visteon, a Ford supplier, teaching them on how infrared can do this in environmental chambers. When I leave, they buy infrared imaging and they put it on their boards and sell to GM, and the boards are good. Okay, we've got specs, engineering specs to meet the criteria for doing certain thermal imaging on boards to make sure they're designed properly and built properly. Okay, things like interlayer shorts, components that have been implemented or put in wrong can be seen quickly. And basically the design of the board. You don't want any big hot spots that char a board under full use, full power. Back to frosters, we can see defects very quickly. It only takes 10 or 15 seconds. Over here you can see some of the grid is gone. This has been implemented in different factories, not just in GM with machine vision. And it's a very, very easy application for infrared machine vision to implement. Exhaust designs, heat shields, heat reflectors. We've had floor pans reaching over 700 degrees Fahrenheit, 1 inch from your toe where your gas pedal is. And that's a oops. You know, we show these vehicles pulling heavy loads through desert environments with floor pans reaching that kind of temperature. We have to get a heat shield in there pretty quickly. So customers would not like that, and that goes across the board, anybody building a vehicle. You know, you need to see what's going on thermally on your floor pans and what's going on with that exhaust. There's a lot of energy going out that tailpipe, and you don't want it heating your car up. Batteries used to be a real warranty problem. South of the Mason-Dixon line, heat can really kill a battery. So we studied the way incoming air can cool it. We can duct air around. We can put neoprene boots over these batteries to try to protect them. One of the things I always like to have accomplished within GM would be to do an emissivity study under the hood so that we can understand everything that we want reflecting infrared, that we put it, make it a reflecting surface, and everything we want absorbing under the hood to make it an absorbing surface. So attacking a vehicle from a thermal point of view, emissivity-wise, would be, I think, worth its weight in gold. I don't know how to make that happen, other than to keep talking to folks and encourage folks to think thermally. So if you get a chance to do that, it'll be cost effective for you, guaranteed. There's some things in there that shouldn't be emitting that are, and they're affecting us. This is a lamp that we looked at on a Bravada back in '97, new material. They were worried about the characteristics, would it stand up to the heat from those lamps, high intensity lamps. So we reached steady state. We can tell when we reach steady state and just document the temperatures, give it to our design folks, and make sure that everybody's happy. Even light bulbs. This was a critical issue years ago. Some of our suppliers were selling us tungsten filaments with defects in them, and we were having an early burnout. And we jumped on that right away. With the right thermal imager, we can look through the quartz envelope and look at the filaments themselves. And we can see hot spots along that filament due to the impurities that are being sold to us. Again, keeping track of our suppliers, looking at our warranty issues can really point the finger at what our suppliers are selling us in their effort to cost cut. It's a whole balance game out there that we try to reach, and this will certainly help you out. In the area of brakes, tire design, suspension, we've tried to encourage this at our proving grounds, looking at things like tire contact, cornering, suspension, keeping that wheel flat on the ground. You would think they would be at every race car in the world looking at this in corners. I mean, they just had a big race this weekend, NASCAR race. I never see a thermal imager in the corners when those tires or those cars are screaming through, slipping along at 200 plus miles an hour. But this will tell you what's going on very quickly. The cameras certainly have the performance to do that. It's just up to the folks like you and I to implement it.